For over a century, the global diamond market was controlled by a single, untouchable rule. That rule was scarcity. We were told that diamonds were rare geological miracles. We were taught that they were forged in absolute darkness, trapped beneath billions of tons of crushing rock, and brought to the surface only by the most violent volcanic eruptions in Earth's history. But today, inside massive, highly secured industrial zones in China's Henan province, tens of thousands of heavy hydraulic presses are breaking that ancient rule. Operating continuously under harsh fluorescent lights, these machines are systematically printing flawless diamonds by the millions. This is not just a technological breakthrough. It is a slow-motion financial extinction event. In just a few years, wholesale prices for these laboratory-forged stones have collapsed by an astonishing 88%, shattering one of the most powerful and heavily guarded monopolies in human history. How did a single, landlocked province harness the brutal physics of the Earth's mantle? And what happens to a multi-billion-dollar empire when the world realizes its ultimate symbol of wealth was built entirely on a mathematical illusion? To understand how a provincial manufacturing hub managed to collapse a global luxury market, we first have to dissect the illusion they were fighting against. Chemically speaking, a diamond is one of the most painfully ordinary objects in the universe. It is composed entirely of carbon. It is the exact same element that makes up the graphite inside a common pencil, the coal burning in an industrial furnace, and roughly 18% of the human body. If you take a lump of black soot, subject it to immense thermal energy, and force its atoms to bond in a highly rigid, three-dimensional tetrahedral lattice, it becomes entirely transparent. It becomes impossibly hard. That is all a diamond fundamentally is, a strict geometric arrangement of incredibly common atoms. Yet, for over 100 years, the global public was conditioned to believe that these small transparent rocks were the ultimate, undeniable symbol of extreme rarity and inherent wealth. This was not a scientific truth. It was a carefully engineered economic construct. In the late 19th century, explorers discovered massive diamond mines in South Africa, most notably the Kimberley mine. Suddenly, the earth was yielding stones not by the handful, but by the ton. If millions of carats were released into the open market, the sheer volume of supply would crash the price, rendering the stones practically worthless. To prevent this financial catastrophe, a powerful syndicate of mining companies, which would eventually consolidate into the De Beers Cartel, realized they had to take absolute, uncompromising control of the global supply chain. They did not just mine diamonds. They bought up the vast majority of the world's rough diamonds from other producers and stockpiled them in highly secured underground vaults in London. By strictly throttling the release of these stones to the public, they engineered a state of artificial scarcity. But controlling the supply was only half the battle. They had to control human desire. In 1947, they launched one of the most successful psychological campaigns in human history. They coined the phrase, "A diamond is forever." They convinced generations of consumers that a diamond's astronomical cost was a law of nature. They established the cultural standard that a man must spend 2 months of his salary to prove his commitment. To protect this monopoly, the industry heavily marketed the violent geological origin of the stones. Natural diamonds are forged deep within the Earth's mantle, approximately 100 miles below the surface. At that extreme depth, temperatures exceed 2,000 degrees Fahrenheit. The ambient pressure is a crushing 50,000 times greater than the atmosphere at sea level. The only reason these stones exist on the surface today is due to ancient, deep-source volcanic eruptions known as kimberlite pipes. These eruptions acted like supersonic geological elevators, firing the diamonds upward at incredible speeds, tearing through the Earth's crust before the carbon could degrade back into soft graphite. The sheer violence, depth, and time required for this process made it seem impossible for humanity to ever replicate it. The cartel believed their empire was invincible. The Earth was their only manufacturer, and the Earth works incredibly slowly. But they severely underestimated the relentless, calculating nature of industrial engineering. While the monopoly was busy guarding its massive open-pit mines in Africa, scientists were quietly figuring out how to build a mechanical volcano. The quest to artificially synthesize a diamond is not new. It began as a highly classified, Cold War-era scientific race. In 1954, a physical chemist named Tracy Hall, working for General Electric under Project Superpressure, achieved the impossible. He designed a massive steel apparatus capable of squeezing carbon so intensely that it crystallized. But those early stones were tiny, yellow, heavily flawed, and purely meant for industrial cutting tools. They were no threat to the jewelry cartel. Fast forward to the 21st century. To build a flawless, gem-quality diamond, you do not need magic. You only need to trap the extreme forces of the Earth's mantle inside a highly calibrated steel box. Today, this box is called the cubic press. It is a massive, multi-ton piece of heavy industrial machinery. It is designed with a single, brutal purpose: to replicate the exact thermodynamic violence of a deep subterranean volcano, and to do it on a factory floor. At the absolute center of this giant machine is a highly engineered reaction chamber, scarcely larger than a golf ball. Inside this chamber, technicians place a tiny sliver of a pre-existing diamond, known as a seed. Above it, they place a block of pure, highly refined graphite. Between them sits a metallic catalyst, usually an alloy of iron, nickel, and cobalt. Then, the machine is activated. 6 massive steel anvils, driven by overwhelming hydraulic force, close in on the core from all 6 directions, locking the chamber in an inescapable geometric grip. What happens next is a masterpiece of extreme quantum physics. The press applies a crushing pressure of 5 to 6 gigapascals. To put that abstract number into physical perspective, it is the equivalent of balancing the entire weight of a commercial airliner on the very tip of your finger. Simultaneously, the chamber is flooded with highly regulated electrical current, driving the internal temperature up to 1500 degrees Celsius. The interior of the chamber becomes hotter than flowing volcanic lava. Under this sustained, calculated assault, the normal laws of chemistry begin to break down. The extreme heat melts the metallic catalyst into a liquid solvent. This molten metal slowly, methodically dissolves the soft graphite block above it. Stripped of their original hexagonal structure, the loose carbon atoms are forced to migrate downward through the liquid metal, moving toward the slightly cooler diamond seed at the bottom of the chamber. Atom by atom, layer by strict molecular layer, the carbon bonds into a perfect, three-dimensional tetrahedral lattice. The machine leaves the carbon atoms with no other physical choice. They cannot remain graphite. They must become a diamond. What takes the planet billions of years to randomly forge in the chaotic darkness of the deep Earth. The cubic press executes with flawless, mathematical precision in a matter of weeks. For the traditional mining cartel, a machine capable of growing real gemstones was a terrifying prospect. But a single machine in a university laboratory is just a scientific curiosity. To truly break a century-old global monopoly, you do not just need the underlying physics. You need terrifying, uncompromising, industrial scale. And that scale was about to be realized in a place the luxury world never saw coming. If you were searching for the epicenter of the global luxury jewelry trade, your first instinct would be to look at the historical diamond bourses of Antwerp, the high-end boutiques of London, or the Diamond District in New York. You would not look to the agricultural and industrial heartland of central China. Yet, the ground zero of the diamond collapse is located in Henan province, specifically within a gritty manufacturing hub known as Henan County. For decades, the factories here had absolutely nothing to do with romance or luxury. They were built to support heavy national infrastructure. Because diamonds are the hardest naturally occurring material on Earth, they are essential for heavy industry. You need them for deep core drill bits, for massive saw blades cutting asphalt, and for precision abrasives in semiconductor manufacturing. Since the 1960s, starting with state-sponsored research institutes, Henan have been quietly mass-producing synthetic diamond grit for industrial applications. They were not growing beautiful gemstones. They were manufacturing microscopic, cloudy, yellow shards of carbon. But in doing so, year after year, they were mastering the extreme physics of the high-pressure, high-temperature process. Over the decades, the engineers in Henan systematically refined their technology. They built larger, more stable cubic presses. They engineered highly advanced cooling systems. They stabilized the local electrical grids required to maintain a flawless 1500 degrees Celsius for weeks at a time without a single power fluctuation. And eventually, they made a mathematically devastating realization. If they meticulously controlled the cooling gradient, purified the carbon source, and sustained the extreme pressure for a few weeks rather than a few hours, the machine would not just produce industrial grade. It would grow a single, massive, optically perfect crystal. The transition from industrial abrasives to high-end jewelry was swift and unprecedented. The factories expanded into massive industrial leviathans. Imagine walking into one of these facilities today. You do not see the sterile, quiet environment of a traditional gem laboratory in Switzerland. You see a colossal manufacturing floor, stretching out like an aircraft hangar under harsh, unblinking industrial lights. Row after row of towering green and gray hydraulic presses sit perfectly aligned, numbering in the tens of thousands. The air vibrates with a constant, deafening low-frequency hum. It is the sound of thousands of captive volcanoes, silently forging what takes nature billions of years to create. By the early 2020s, Henan province was responsible for an estimated 80% of China's synthetic diamond production and a massive share of the global total. They were suddenly capable of printing millions of carats every single year, operating at a scale that the traditional mining cartel could not even comprehend. Initially, the established diamond industry publicly dismissed this Chinese manufacturing boom. They assured their investors and the public that synthetic stones were just cheap imitations. They launched aggressive marketing campaigns arguing that a discerning buyer or a trained gemologist would always be able to tell the difference between a real diamond and a factory-printed clone. But this defense was fundamentally flawed. It relied on a deliberate misunderstanding of what the cubic press was actually doing. The traditional industry was about to discover a terrifying scientific reality, one that would throw the entire global grading system into absolute panic. For decades, the traditional jewelry industry had trained the public to easily spot a fake diamond. If you brought a piece of glass, a cubic zirconia, or a moissanite to a jeweler, a simple thermal probe or a magnifying loupe would instantly expose the imitation. The cartel relied heavily on this exact narrative to defend their empire against the Chinese cubic presses. But they were deliberately confusing a fake diamond with a synthetic diamond. The stones emerging from the heavy hydraulic presses in Henan were not imitations. At a subatomic level, they were pure, crystallized carbon. They registered a perfect 10 on the Mohs scale of hardness. They bent light with the exact same refractive index. They possessed the exact same thermal conductivity. If you handed one to a master gemologist with decades of experience and asked them to find the difference using a standard optical microscope, they would fail. Because there was only one reliable way to identify a diamond forged in a Henan factory, it was simply too perfect. When the Earth creates a natural diamond, the process is incredibly chaotic and messy. The carbon lattice often tracks microscopic traces of nitrogen, boron, and other geological debris from the mantle. These create tiny internal flaws known as inclusions. Over 98% of all natural diamonds contain these structural imperfections, specifically nitrogen impurities, classifying them as Type IIa diamonds. But a cubic press does not operate in the chaotic dirt of the Earth's mantle. It operates in a highly controlled, sterile, vacuum-sealed environment. Because the engineers in Henan could completely eliminate nitrogen from the reaction chamber, the stones being pulled from the machines belong to a totally different category, known as Type IIa. In nature, Type IIa diamonds are the most chemically pure, optically flawless stones in existence. Because they lack nitrogen, they transmit light with absolute perfection. They are so incredibly rare that they make up less than 2% of all mined diamonds. Historically, they have belonged almost exclusively to royalty, museums, and billionaires. The famous Kohinoor and the Cullinan diamond are Type IIa. The factories in Henan were not just replicating average, commercial-grade diamonds. They were mass-producing the rarest, most perfect category of diamond on the planet. The traditional industry suddenly faced a terrifying paradox. The only way to prove a stone was a natural geological miracle, and therefore justify its astronomical price tag, was to use highly advanced, multi-thousand-dollar spectroscopy machines to look for its structural defects. The cheaper, factory-printed clone was actually scientifically superior. The industry had spent a century convincing the world that flaws reduced a diamond's value, and that perfection was the ultimate goal. Now, the Chinese factories were handing them absolute perfection, and it was destroying them. Once consumers and wholesale buyers understood that geology had been decisively beaten by industrial physics, the artificial value system holding up the global monopoly began to severely fracture. And what followed was a financial collapse moving at a terrifying speed. When the global market fully digested this scientific reality, the mathematics of artificial scarcity instantly disintegrated. Between 2016 and 2024, the wholesale price of synthetic diamonds began a catastrophic descent. As the factories in Henan scaled up their fleets of cubic presses, adding thousands of new machines every year, the cost of production plummeted. Driven by relentless industrial efficiency and fierce competition among Chinese manufacturers, the wholesale value of these laboratory-forged stones collapsed by up to 88%. This was not a gentle market correction. It was a financial freefall. A product that was chemically identical and structurally superior to a natural diamond was suddenly available for a mere fraction of its historical cost. A flawless, 1-carat lab-grown diamond that might have cost thousands of dollars a decade ago was suddenly trading for a few hundred. The traditional mining cartel, completely exposed, was forced into a desperate, defensive war. For a century, they had strictly controlled the physical supply of stones pulled from the dirt. But they possessed absolutely no leverage over a manufacturing revolution happening entirely inside another country's industrial sector. In a bid to survive, the legacy corporations attempted a radical and counterintuitive strategy. First, they began quietly, then aggressively, slashing the prices of their own natural rough diamonds in key categories. Market data revealed sudden price drops of up to 40% for select natural stones, effectively wiping out billions of dollars in perceived global wealth in a matter of months. Then, in an even more paradoxical move, the original architects of the diamond monopoly began manufacturing their own synthetic stones. In 2018, De Beers launched a brand called Lightbox, deliberately pricing their lab-grown diamonds at a flat rate of $800 per carat, far below what other lab-grown competitors were charging at the time. It was a calculated psychological tactic. The goal was to anchor the price of synthetic diamonds as low as possible, to fundamentally devalue them in the eyes of the consumer, and convince the public that anything made in a machine was just cheap, disposable fashion jewelry. But the strategy catastrophically backfired. By openly acknowledging, manufacturing, and selling synthetic stones, the cartel accidentally validated the technology to the consumer. In the same year, the United States Federal Trade Commission officially ruled that a diamond is a diamond, regardless of whether it was mined from the earth or grown in a lab, removing the word natural from the fundamental definition of a diamond. The Henan factories did not slow down. They simply kept printing. They optimized their electrical grids, upgraded their heavy hydraulic anvils, and continued to flood the global supply chain with flawless, Type IIa carbon crystals. The 88% price crash of synthetic diamonds did not just make lab-grown stones cheaper. It acted as a massive, unavoidable wrecking ball against the natural diamond empire. It proved to the entire world that the astronomical price of a diamond was never actually based on the stone itself. It was based purely on the strict, corporate control of its availability. The cubic presses of China had achieved the impossible. They had taken the ultimate global symbol of elite wealth, stripped it entirely of its mythological rarity, and transformed it into a mass-produced industrial commodity. Yet, as the dust settles on the collapse of this century-old monopoly, a much larger, more unsettling question remains. Today, if you walk through the massive industrial zones of Zhejiang County, the cubic presses do not stop. The low-frequency hum of tens of thousands of hydraulic machines continues, day and night. Every few weeks, technicians open the heavy steel chambers to reveal carbon crystals of absolute, terrifying perfection. The collapse of the global diamond monopoly was never really about jewelry. It was a raw demonstration of extreme industrial dominance. It proved that human engineering has reached a point where it can bend the most violent physical forces of the planet to its will, mass-producing what was once considered a rare geological miracle. The 88% price crash shattered a psychological illusion that held the world captive for over a century. It forced us to confront an uncomfortable economic truth. In an age where absolute perfection could be mathematically printed on the factory floor, true scarcity might no longer exist. If a steel machine can replicate the fiery heart of the earth to crash the diamond market, what other impossibly rare materials will industrial physics conquer next? The earth took billions of years to build an empire. A steel box in Henan broke it. If you enjoy journeys into the hidden systems and industrial forces that shape our world, subscribe for the next documentary.